Hello, my name is Arthur Applegate, and here is my project on Latin square designs. First thing to note about a Latin square design is that the main purpose of it is it's a method of organizing data, specifically comparing two different factors and how they relate to each other in different examples. Now, there are actually two types of Latin square designs. There is the normal, and then there is a Greco-Latin square design. Those are more for controlling more fine-tuned experiments, but I'm talking more along the lines of a normal Latin square design. Another thing is that the biggest purpose of this Latin square design is to show that data is never repeated, which eliminates all unnecessary repetition, which can save time in the long run if you don't have to go over every single little thing if it's repeated. That is what a Latin square design is. Now we will go over why we would use it. There are advantages and disadvantages, as with any type of method of organization, always pros and cons. The main advantages to using a Latin square design is that you can control the variation in two directions. In most standard graphs where you're just comparing one treatment along multiple different tests, that's just controlling one degree of variation, just varying what is happening in each test. How is the outcome different? But in this case, you can actually view perhaps one treatment is done different from another. You can control the variation in each situation in both the treatments and the tests that are being put through. Another good advantage is that you can easily add another row and column to adjust for any unseen treatments and tests that you need to test this through. The disadvantage of this, however, is that you must have an equal amount of rows and columns for the algorithm that determines that data is never repeated to stay true, and it also assumes that the factors in each row and column are independent of each other. That's not always the case, as some specific examples would see the factors between the rows and columns actually having an effect on each other than each individual test. Now, an example of using this type of organization in an engineering field would be if a company was testing the different titanium steel alloys, for example. As you see, I have titanium steel alloy A through D, and they tested them in 4 tests to see their maximum stress, shall we say. As you can see, they would test it 4 times, one for each alloy, and they would compare the results. As you can see, this is very good for this because you would not have any repeated data, and it would save the people analyzing this data much time, as they don't have to go through repeated unnecessary data. And here is my reference page.